Dun, dun, dun. Hello! We need to do two things. One, we need to pick where 0 is. And two, we need to pick which way is positive and which way is negative. Now don't have a negative attitude about it because this is going to be great. Alright, so if we're drawing a graph, we need to pick where 0 is. And that's up to you. You get to decide where 0 is. Whatever floats your boat. Look, it's a boat. So for this video, basically where that tree is, let's call it 0. So that tree back there is like your reference line for 0. Okay? Okay, let's talk about which way is positive and which way is negative. You might be tempted to say that to the right is positive. Well, then that's that way, right? No. You're probably looking at me funny because your right is that way. So because we're facing each other, using right and left is not going to work great. So let's just say that that way is positive. Does that work? I think so. Doesn't matter. You get to decide which way is positive and which way is negative. So let's just say that that way is positive and that way is negative, horizontally. So if I'm moving in that direction, I am moving in the positive direction, and if I'm moving in that direction, then I'm moving in the negative direction.
All right, velocity versus time graphs. I'm not going to speed through it because it's important to understand these. I'm going to show you how to draw velocity versus time graphs, and I'm going to tell you what information you can get from velocity versus time graphs about the motion of an object. Velocity versus time graphs show you what's happening to the velocity of an object as time is passing. Okay, so this is a velocity versus time graph. So similar to a position versus time graph, on the horizontal axis we're going to have time, or t for time. Time is measured in seconds. And on the vertical axis we are going to have velocity, which is measured in meters per second. Just a reminder, velocity is a vector, which means it has both magnitude and direction. So the graph is going to reflect that. The graph is going to show what happens to the speed of an object as time passes, and the graph is also going to show what happens to the direction of that speed as time is passing. Okay, so this here is our 0. So this horizontal axis here represents when the velocity is 0. This direction we're going to call positive, and this direction we're going to call negative. So this is our 0 reference line. This is where our velocity is 0, meaning an object is not moving. Anything above that means the velocity is positive, meaning the object is moving in the positive direction, and anything below that means the velocity is negative, meaning the object is moving in the negative direction. Okay, so when I'm approaching drawing a velocity versus time graph, just like a position versus time graph, I start with what's happening at the beginning. So for a velocity versus time graph, I say, okay, what is happening at t equals 0? What is the velocity of the object at t equals 0? Now, when we're determining the velocity of the object, we need to look at the speed, or how fast the object is moving, and the direction in which the object is moving. So you need to look at both the speed and the direction. Okay, in all three of those videos, the graph is actually going to be the same. At the beginning, the person is not moving in all three of those videos, which means that their velocity is equal to 0. So at the beginning, time equals 0. My velocity is not positive, it's not negative, it is 0. So this is where I'm going to start. And as time is passing, does that velocity change? It does not. The person never starts moving. So their velocity does not change. It stays 0 the entire time. So my graph is going to look like a horizontal line along this axis. So for all three of those videos, your graph would look just like this, because in all three of those videos, the object is at rest the entire time. So on a velocity versus time graph, if you see a horizontal line along the horizontal axis or at 0, this means that the object is at rest or not moving because the velocity is 0. Alright, in this video, I start with what's happening at the beginning. At the beginning, the person is moving. So the person starts out moving, which means they have a velocity. So the person has a speed. Now the question is, which direction is that speed in? Is it in the positive direction or is it in the negative direction? Remember, at the beginning of the video, we chose which way was positive. And so, in the video you just saw, you can see that the person is moving in the positive direction, which means that they have a positive velocity. So at time equals 0, I have a positive velocity. I go up for positive. So now, as time is passing, what's happening to that velocity? Is it changing? We have to look at both the speed and the direction. Does the speed change as time passes? No, the person is moving at a constant speed the whole time, right? They're not getting faster, they're not getting slower, they're just trudging along on their hands. Doesn't matter that they're walking on their hands, they are still moving at a constant speed. And the direction does not change. The direction they were moving at the beginning is the direction they are moving the entire time. So my graph is going to look like a flat horizontal line because as time is passing, the velocity is not changing. So when you see a horizontal line, a flat line that is not at 0, right? We have a positive velocity here. This represents having a constant speed. Okay, so the object is moving at a constant speed. Okay, next video. Similar to the last video. So I'm looking at what is the velocity of the person at time equals 0. Well, at the beginning, the person is moving, they have a velocity, and they are moving in the negative direction. So at t equals 0, I come down to the negative side of the graph. So it does make a difference whether I start the graph here or here. So in this video, the person is moving at the exact same speed that they were in the previous video for this graph that we drew here, this blue line. So in both of those videos, the speed was the same, right? The only difference was the direction. So for this video, I'm going to be on the negative side of the graph. So I'm taking into account the direction. However, the speed, the magnitude of the speed was the same, which means that I should be the same distance away from 0. So whatever distance I was away from 0 here should be the same distance that I am away from 0 over here, except I'm going in the negative direction. And that's where velocity comes into play, because in both of those videos, the speeds were the same, how fast I was moving was the same, but the directions were different. As time passes, the speed does not change and the direction does not change, which means the velocity is constant, and I get another flat horizontal line representing constant speed, but in the negative direction. Okay, in this video, at the beginning, at time equals 0, the person is moving. They are moving in the positive direction. So that means we're going to be on the positive side of the graph. But now I need to think, where along the axis do I start? Well, in this video compared to the last two videos, what's the difference? Well, the person is moving a lot faster. Their speed is greater. So we're moving in the positive direction, but they have a greater speed. So we're going to start up higher. Their speed is more positive. It is a bigger speed. And as time is passing, the speed doesn't change. They're still moving at a constant speed. They start out faster, but they maintain that fast pace and that direction, which means that they have a constant velocity and again a flat horizontal line. So the difference between this line and this line is the magnitude of the speed. But for both of these graphs, the object is moving in the same direction, which you can tell because they have a positive velocity, meaning they are moving in the positive direction. But this object is moving faster than this one. They have a bigger speed, a more positive speed. Remember, the farther away your line is from zero, whether positive or negative, the faster your speed is. Okay, in this video, similar to the last one, at time equals 0, the person is moving, so they have a speed. So we need to think about the direction. Well, they're moving in the negative direction, which means I'm going to the negative side of the graph. So where along this axis do I start? Well, the person is moving at the same speed that they were in the previous video. So the magnitude of the speed, how fast they're moving, is the same. The only difference is they're moving in a different direction, which is why we're on the negative side of the graph. But because the magnitude of the speed is the same, our distance away from 0 should be the same as the previous video. Okay, as time passes, they maintain that speed in that direction, which gives us another flat horizontal line representing a constant speed. Okay, and so notice from the previous video and the video that you just saw, you can tell that both of those objects have the same speed because they are the same distance away from 0. They're moving at the same speed. The difference is they're moving in opposite directions. Okay, so for both of those videos, the velocity versus time graph is going to look the same. Here's why. So again, we start with, what is our velocity at the beginning? Well, at time equals 0, in both of those videos, the person is not moving. Our object is at rest, which means we are going to start here, where our velocity is equal to 0. We don't care about the initial position of the person because we're drawing a velocity versus time graph. So, for both videos, we're going to start at 0 because they're not moving. Okay, so now what's going on as time passes? Well, the person starts from rest, and then they start moving, at first slowly, and then they start getting faster and faster and faster. So in these videos, the velocity is changing because the person is getting faster, the speed is changing, which means we're not going to have a horizontal line anymore because our velocity is changing. My speed is increasing, so my velocity is increasing. Well, which way? Is it becoming more positive or more negative? Well, the person is moving in the positive direction in both cases, which means our graph is going to go to the positive side. Okay, so what this graph is going to look like is a straight diagonal line. Because as time is passing, the velocity is getting more and more and more positive because they're getting faster and faster in the positive direction. What's going on at the beginning? Well, at time equals 0, the person is not moving. So we start with velocity equals 0. What happens as time passes? Well, what happens to the speed? Well, the person starts out stopped, and then they start moving slowly, then faster, then faster, then faster. So we know their speed is increasing. What about the direction? In which direction is their speed increasing? Well, the person is moving in the negative direction, which means their velocity is in the negative direction, which means their speed is increasing in the negative direction. They are getting faster and faster in the negative direction. So our graph is going to be a diagonal line. Our velocity is not constant. They're not moving at a constant speed, so no horizontal line. The velocity is getting more and more negative as time passes because they are moving faster and faster and faster in the negative direction. Okay, so the key takeaway from these two graphs that we've just drawn in the green is that when you have a graph that is pointing away from 0 as time passes, so as time is passing, This graph is moving away from 0 in the positive direction. This graph is moving away from 0 in the negative direction. So on a velocity versus time graph, if the graph is going away from 0 as time passes, that means that the object is speeding up. They're getting faster, whether that's getting faster in the positive direction or in the negative direction. Okay, at the beginning of this video, the person is moving. So they have a velocity at the beginning. So they have a speed. Now we need to discuss which direction that speed is since we're talking about velocity. They are moving in the positive direction, which means they start out with a positive velocity at the beginning. What happens as time passes? Well, the person is going very fast at the beginning, and as time passes, they start slowing down and slowing down and slowing down until they come to a stop. And remember, if something is stopped, it's got to have 0 velocity. Remember, this line represents having 0 speed, not moving. So our graph is going to start with a positive velocity, but then it's going to end with 0 velocity because the person ends up at a stop. So I'm going to draw a diagonal line, and voila. So they're moving in the positive direction, but they're slowing down. Okay, in this video, the person starts out with the speed. They're moving at the beginning. That speed is in the negative direction. They're moving in the negative direction. So at time equals 0, they have a negative velocity. They're moving quickly at the beginning. As time passes, they start to slow down. They slow down and slow down until they come to a stop. Okay, so it's going to look similar to the previous graph we drew. So we know that we need to end at 0 because they end at a stop. So they start out moving fast with a large negative velocity, and then their velocity gets less and less negative until it gets to 0, until they come to a stop. So their velocity here is getting less and less negative because they're slowing down to a stop. So both of these blue graphs are moving towards 0 as time passes. On a velocity versus time graphs, a graph that is moving towards 0, whether that's coming from the negative side or the positive side, means that the object is slowing down. So that's key. Graphs moving towards 0 on a velocity versus time graph means that the object is slowing down. Final example, this one's important. So what happens at the beginning? Well, at time equals 0, the person is moving, they have a speed, and they are moving in the positive direction, which means that we start up here. And we start with a positive velocity. What's going on as time passes? Well, at first, the person starts to slow down, right? They're moving fast, and then time is passing, they're slowing down, slowing down, until they get to a stop, which means that at some point we have to touch the velocity equals 0 line. So we can draw the first part of our graph, right? It's going to look similar to this one because we're slowing down at the beginning, right? So the person starts with a positive velocity because they're moving in the positive direction. They start slowing down, they slow down and slow down until they come to a stop. Then what happens? Well, the person turns around and starts moving in the negative direction. They begin to speed up in the negative direction. So at this point, they're at rest, they're not moving, and then they start to go faster and faster and faster in the negative direction. So their speed, their velocity is going to increase in the negative direction.
And remember, we always have to draw to the right because time is moving forward. The question is, does our graph point upwards or downwards?
Again, they started out with a positive velocity. They're moving fast in the positive direction. They continue moving in the positive direction, but they're slowing down our graph is getting closer to 0, meaning they slow down until they get to rest. Then, once they're at rest, they turn around and start speeding up in the negative direction, which you can tell because our graph starts to move away from 0. Here we were moving towards 0, meaning we're slowing down. We get to 0, and then they turn around and start speeding up in the negative direction, which you can tell because the graph is moving away from 0. What's important to get from this is that on a velocity versus time graph, when a graph crosses 0, when you cross 0, that means the object turned around. Because here they have a positive velocity, which means they're moving in the positive direction, and then once they cross 0, they're now moving in the negative direction, which means they turn around.